Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Thank you so much for joining me and our wonderful presenters today on this DevOps.com webinar, Monitoring Your Migration to GCP with Datadog. We have an awesome webinar for you today, as always, but before we get started, I need to go over a couple housekeeping items really quickly. Today's event is being recorded, so if you miss any of it, you can go back and watch it again. We'll be sending an email, with a link where you can access that afterwards, or you can go to devops.com/webinars and it will be there for you as well. We are taking questions from the audience throughout, and we'll have a little bit of time at the end for Q&A. So make sure you use the Q&A tab there on your console to get your questions in. We will be doing a drawing at the end of today's webinar for 4 $25 Amazon gift cards. So stick around till the end to see if you are a winner. And I am pleased to introduce today our speakers. Richard Seroter is Director of Outbound Product Management at Google Cloud, and Aaron Kalin is a Technical Evangelist at Datadog. Welcome, both of you. Excited to see what you've got in store for us today. And I'm going to put myself on mute and turn my camera off and let you get right to it. Thanks.
Sounds great. Thanks for having us. Yeah, so I'm Richard. We have Aaron here. He's going to take the second half as we look and jump right in to the material today. What are we going to spend our time on? Well, I'll start off and discuss a little bit about how do you choose where to run. First of all, in a cloud migration, where do you run your stuff? How do you choose which container runtime? What's the right choice for your team? Things like that. I'm going to try to give you a mental model to use for your own systems. Aaron's going to dig into kind of as we think of observability, regardless of where you migrate to. Now, how do you actually get a better picture of what's actually going on in your environment? We can't just spend the whole time in slides. So Aaron's going to grace us with a demonstration as well. And we're going to leave a good 10, 15 plus minutes at the end to do some Q&A. So pump questions in there. We're here to answer questions and challenge some of the ideas, let us know some of your perspective and help make us all smarter here today. So I'll jump right in. So as we look at Google Cloud containers, just in general, whether you're using Google Cloud or otherwise, I hope that a lot of these ideas will come in handy. So look, when we're doing any sort of cloud migration, it's not one thing, right? We're moving all kinds of stuff. You're moving compute, of course, but you're moving data things. You're moving all your network architecture and connectivity. You're moving all that middleware, some of that sticky stuff of messaging infrastructure, identity systems. You're moving dev sandboxes. You're moving source code repositories. You're moving all the processes, right? You shouldn't be doing the same processes that you were doing on-prem for change requests or provisioning or things like that. When you move to a cloud, you start to modernize those. But we'll spend time zeroing in on compute today because we don't have a 12-hour webinar slot here. Somehow, I guess those aren't approved. So we're going to focus on compute just for this one. And what are the things we should be thinking about when it comes to compute? So as much as I can scour the internet, and you can too, for that sort of really simple decision tree, like I have an app, where should it run? Here, 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 here. And you play Plinko and you get down to your proper thing. It doesn't really work that way. And to me, it's because there's 3 factors that we don't often consider. So if you're looking at where I should run something, workload, of course, comes into play, right? What is the characteristics of the thing itself? But also the team. Who's the team building and running it? It's a huge factor. I might give completely different advice for the exact same application based on the teams that would be owning it, right? And same with strategic factors. Even based on those first 2 factors, you might have a completely different answer based on what your corporate strategy was or where you were making big bets. So all of these to me are interrelated. You can't just say, hey, it's a Java web application. You should absolutely turn it into a bunch of functions, or it should go into a container in this environment. That's way too simplistic. So let's dig into that a little bit. So what questions would I be asking in those vectors when I'm trying to make the right choice? And so when we think of workload factors, I don't know, what do we care about? Is this new or existing, right? Because a new application, okay, you don't have any sort of baggage, you don't have any technical debt, you don't have any constraints that might really impact where I run one place or the other versus existing. Hey, I've got certain things I have to consider, dependencies, support structures, all that stuff. Is it Windows or Linux? Sometimes this can be a completely deciding factor because you can't choose to really run a Windows function necessarily in a Lambda or in certain places. So you have to think about, well, what's the operating system this thing depends on? And of course, what kind of consumption does this need? Are you running something that requires 16 vCPUs or 40 gigs of RAM, or is this just kind of a tight, small service? Or is this running, does it need a petabyte of storage? All these things are going to impact where you might run it, right? That workload characteristic. Is it stateful? Does it actually have local state or in-memory state that it depends on? Or is it actually storing state off in an object store, in a database, in a network-attached file system, right? That can impact what is the best choice for where I run this. Is it bursty? Do you have very unpredictable usage? Hey, it's the end of the month and we run payroll and we beat the daylights out of this system, and 29 other days of the month it does nothing. Or is it just kind of steady consumption the whole time, and so you need some predictability in what you're doing? And this one's one, again, I don't know if we always consider, but is that workload encapsulated? Meaning, does everything it need come with it? Or does it rely on, hey, a service running on that box or a driver that's been pre-installed or things like that, right? That can totally dictate what the right place to run your software is based on how encapsulated that software is. Do you care about portability? When I'm migrating from on-prem to a cloud or between clouds or whatever, do I care if this thing only runs in one place? Or does it need to run all over the place? And of course, for this one, and frankly, I'm going to do this for all of them, what are you trying to get better at? Like, I don't think we just want to migrate stuff. That's the equivalent of just, transferring my debt to a new credit card with a lower interest rate. Like, I still have the debt, right? I want to pay stuff off. So what am I trying to get better at here? Am I trying to, introduce new technology? Am I trying to deliver faster? And so I'm thinking about how I ship faster. All of these things matter a ton. Now let's talk about the team. Because again, you could give me the exact same characteristics for that workload, and based on which team was going to run it, I might give you two different pieces of advice. So what the team characteristics would I ask for? Well, how do you ship software today? Like, is this you package it up and you send it to Harry and he somehow deploys it? Do you have everything on a pipeline? Is everything go to VMs? Like, how do you ship software? What is your process like? What is your tool chain? Are you even into containers at the moment? Is this brand new to you? Will this be the first time you containerize something? That could impact where you go. Who's building and running the software? You have a software team that writes code and checks it in and they're done, and an ops team deploys it and runs it. All right, that might be a different profile for where you decide to run that software. What are you used to? Like, what did you come from? Did you come from a hypervisor environment? That's all you've had? Or you just run OpenStack? All right. Were you running a Cloud Foundry environment? Do you only use Heroku? Like, what is your right frame of reference for this? Because again, certain things will feel dramatically different based on where you're coming from. And again, what are you trying to get better at as a team? Are you trying to create more independence in your teams? Are you trying to up-level a certain skill set? Are you trying to actually learn things like containers as a group, and therefore that's important to you? So thinking again, where am I trying to get better as I migrate workloads from one place to the next comes into play here. And then finally, strategy factors. Like, zoom out and go, all right, even based on these things, how might I make a choice? So you have major technical bets. Are you an SAP shop? And so that's the center of your universe. Are you saying that we have a goal of going to the cloud entirely in the next 18 months? Are you doing the opposite and say, hey, look, cloud is only for certain things. We really need to stay on-prem. Like, these are major bets that will have a real implication on what you decide to do here. What is your strategy for migration? Are you looking at kind of lifting and shifting and just evacuating where you are? Are you looking to do some kind of improve it locally and then move it, or then first move it, then improve it? Are you rewriting a bunch of software? Are you just turning stuff off? Right, what is your actual migration approach? How fast is your cloud adoption? If you are going to Google Cloud, you're going to another cloud, you kind of taking it piece by piece? Are you just shoveling workloads as fast as you can to another cloud? Did you outsource help to get you there faster? You know, that again can impact what kind of runtime you would choose for your app as you migrate. Do you care about multi-cloud? Are you actually using a few different places to run your software when you migrate from where you are today? Or are you just committed to one place, which again can change your focus? Cost predictability. Do you care? Yes, you care to some extent. It can't be completely bonkers up and down, but how much am I focused on kind of innovation and speed and expansion with some kind of guardrails versus, hey, we're trying to control cost right now. We don't want to have things that are wildly unpredictable. Totally fair. But knowing that is going to dictate what you choose on those other two factors. And again, what are you trying to get better at strategy-wise? Are you not nimble enough? Are you not meeting your customers where they are? Did the COVID stuff really knock you back and you're watching other people who are building better digital experiences? All of these things to me are going to answer the question of where do you want to run? So if you know these, so if you kind of have a sense of these and go, all right, this makes sense. Now, where do I go based on answers to these? So let's talk about that. And again, overlay, yes, I'm biased towards Google Clouds where I work. They do pay me. I do like it a lot. So you might look at this and go, all right, but I use Amazon, fine. Then in your mind, put EC2 on this or put whatever on the next. So this should apply universally, regardless of which cloud you're using. But for Google Compute Engine, this is our globally distributed VM service and predefined. You can pick your resource configuration. You can pick ours. Hey, here's what a medium looks like. Hey, this is for GPUs. It's VMs as a service. We're all pretty familiar with this world. And what's the strategic fit? So if I'm migrating to a cloud, I would be using Compute Engine for lift and shift. Sure. Obviously, I'm evacuating an on-prem hypervisor. I just want to take that VM, which I know how to operate. It's encapsulated with the workload I need. Get this thing to the cloud. Awesome. Good fit. This is probably going to be the most familiar to you for your current state, especially if you're coming from on-prem dominant environment. Hey, this works. I know how to do monitoring. I know how to do deployments. I know how to do logging. I know how to do troubleshooting, all kinds of fun stuff. Like this works for me. Totally makes sense. So what would I deploy here? Well, I would deploy packaged software, right? As much as I can deploy more and more packaged software to container environments, when I'm buying big off-the-shelf software, still VMs is a great place to stick it. Windows is still going to get the most priority in these sort of environments if you're running a Windows-based workload. If I need those big honking boxes with 100 gigs of RAM and I'm doing all kinds of wild stuff, awesome. That's probably going to be a VM or a terabyte of RAM. That's going to be a VM, probably not a container. Virtual desktops, right? I need access to the host to deploy drivers and to do things on the local file system. VMs are awesome for that. For the team, again, we're looking at all those factors, strategy, workload, team. If you're an IaaS-friendly place, right? You've been doing OpenStack, you've been doing KVM, you've been doing vSphere. This is going to feel really comfortable, right? You've got traditional, well-proven operational skills for how you provision and manage infrastructure. This is going to feel super normal. This won't feel super crazy. This is a great way to get into the cloud. Now, as I think of Kubernetes, this is at this point, it seems like the predominant way people run containers when they deploy them. Our service in GKE has been the original Kubernetes service. We launched, I think, back in 2015. It was the first managed service. It's the most scalable, most secure, kind of the one you'll find in the cloud, just given how we've tuned and tested this thing. It's pretty impressive stuff. When would I use it, though? Like, what's the strategic fit? Well, if I'm doing kind of the move and improve strategy, meaning, hey, I'm not going to just fix it locally and then get it to the cloud. I'm going to get it to the cloud, get some incremental improvement by doing that, and then kind of improve the software once it's in its new home, kind of move and improve. Or if I'm looking to say, hey, look, I have a bunch of VMs that run at 5% utilization. I should really containerize these darn things and run them on a larger cluster and just eliminate a couple thousand VMs into a couple of large clusters. I'm just bin packing. I'm just trying to higher density. Makes a ton of sense strategically for cost savings purposes. Workloads, at this point, Kubernetes is pretty good for not just the modern stuff. It's not just this kind of 12-factor web app stuff. This is for commercial applications. Bring your legacy Java apps, bring your Windows applications, right? Bring some packaged software. You're seeing a lot of commercial software now get distributed in a Kubernetes-friendly format, which is great. Same with databases and stateful things like messaging engines. Short-lived things where you got to spin up 100 containers and do some batch processing, or things that you actually want to keep running for weeks and months on end. Right? At this point, Kubernetes has kind of the question is more, what shouldn't I run here versus what I should, as this is proven to be a very stable platform that we're all probably going to depend on for the next decade. What's the team fit, though? I mean, for the most part, if you're using a public cloud Kubernetes service, you need average to somewhat expert skill with Kubernetes, right? There's some responsibility on you to understand architecture. How do I do ingress? How do I do networking in this thing? How do I handle storage? What's troubleshooting look like? You have to have some familiarity in most Kubernetes services to really figure it out successfully. Now, we've extended that. A couple of weeks ago, we shipped something called GKE Autopilot. And GKE Autopilot is kind of a new mode of operations for Kubernetes. It's GKE. It's just hyper-automated GKE with a bunch of sensible defaults that we set, and then we manage the whole thing. So you have zero day two operational stuff to go with Kubernetes. You just provision it, we scale it, we patch it, we upgrade it, we troubleshoot it, we own it. We're the site reliability engineer for you. And so in this case, again, it's really handy for people who want us to take all the responsibility. They want the Kubernetes API. They just don't want the ops, right? They want to have that API for their dev teams, their operators, their partners, but they don't want all the operational costs. So strategically, Like, we want to make a bet on Kubernetes. We do not have the horsepower at the moment to run it, nor do we want to, because we're not in the Kubernetes business. We're in the banking business or retail or whatever you're in. The workload, pretty similar. It's just still regular Kubernetes in this case. It's regular GKE. Now, it's not things that you need to hyper tune. It's not going to be certain workloads where you want the rawest access to all the knobs and switches of Kubernetes, because we own that in this model. You would go back to the standard GKE. For team fit, this is actually great for kind of low to average skill with Kubernetes. Hey, a dev who just wants a Kubernetes environment, let's give them this. Why does that developer need to learn Kubernetes ins and outs just to use that deployment service to run their apps? Use Autopilot. It's awesome for fast teams. Now, if I look at Cloud Run, this kind of keeps moving up the spectrum. This is our kind of scale to zero serverless container platform. I have a container, you take it, you give me a routable endpoint, you scale it to zero if nobody's using it, have it respond to events. Hey, I just dropped a file into this bucket, go spin up this thing to do something. Cool. Kind of event-driven, almost like function as a service, but based on containers. This is great if you're upgrading from a modern PaaS, or maybe from a legacy PaaS to a modern one. Saying, hey, I like platform as a service. I like giving my dev teams kind of really easy app abstractions. I don't want them to know infrastructure. They shouldn't. Let me just have them package in containers, deploy this thing. We're trying to not just do infrastructure in Kubernetes, we're also trying to move to app abstractions. Makes a ton of sense strategically. So this is going to be your right fit for custom-built web apps. I'm not going to go deploy commercial software here. I'm not going to deploy things that need 20 gigs of RAM. Right? This is kind of 4 vCPU, 8 gig of RAM, Linux-based web workloads. They make a ton of sense here, which is a lot of things that actually fit nowadays. For teams, this is great for rapid innovation. Right? I'm taking no ops cost. Heck, we have a free tier that's actually hard to get past. So you can use a lot of Cloud Run before we even charge you for it. So it's a great thing for people experimenting, for people trying to deploy lots of different web applications, and they really want no ops. This is a great fit. Now, if we look at Anthos, something I spend a lot of time with, this is really the idea behind how do I take fleets of clusters and kind of manage them uniformly as one consistent pool. So how do I take all these distributed infrastructure, whether it's on-prem, whether it's in our cloud, whether it's in AWS, whether it's in Azure, whether it's on bare metal, vSphere, doesn't matter. How do I take our GKE, put it in all those different places, and then manage it from the cloud? Is really the value proposition. That's so strategic fit. Go back again to our principles. Strategic fit is, hey, I have fleets of clusters. I'm choosing different clouds, or I'm just doing hybrid plus a public cloud. And I want to use the same sort of skills. I want to use a cloud-first approach. I want to bring the cloud to where I am versus maybe stretching where I am to the cloud. And so my goal here is I'm trying to speed cloud adoption, but I want to use kind of cloud best practices. This is great for some of your modern apps. This is actually really good for some of your legacy as well. It comes with a modernization tool that sucks workloads out of virtual machines and creates containers out of them. So it's a great way to start accelerating your cloud adoption in a lot of ways, as well as running packaged commercial software. And this is good if you've got some Kubernetes knowledge. This is hard if you've never touched it before, but we're also trying to simplify what it means to use GKE everywhere. And so, as I kind of close this part out, really the most important thing, if I had you take away from this, is first off, this isn't 10 years ago. When you chose a compute runtime, you also had to invest in an entire stack, top to bottom, right? You chose this platform. Even in your data center, you probably have this now. I choose this environment, and I am betting on a hypervisor and storage and network and identity and blah, blah, blah. At this point, when I'm in, let's say, Google Cloud, the key is that all these things I'm showing you here are the same for any of those storage options I just showed you. Right? They're all sharing the same logging subsystem and monitoring and identity system and cloud networking and storage and all those sorts of things. So really, you're just choosing the right place to literally host the app. The rest of it stays the same. Your switching cost is super low. Start in Cloud Run and then move the same thing to GKE with no code changes. It's fine. It's not a big deal. So once you're really investing in the cloud, switching between runtimes is relatively straightforward. So as you look at all those, right? Don't just say, hey, it's a .NET app, therefore it goes here. What's your team profile? What's your kind of strategic factor, right? What am I banking on? What am I betting on? How do I make the right choice there? So hopefully this is a good mental model for thinking about this. It's helped me kind of chew through this. And while it isn't as simple as a little 4-step flowchart, hopefully it's more realistic as you figure out how to get to the cloud faster. But I want to hand over to Aaron, because as we think about how do we actually monitor and maintain and troubleshoot across these environments, regardless of where I'm at. Like whatever you choose. I don't care if you choose containers, you choose in a VM, if you run your own Kubernetes on VMs, whatever you do, how can we have some standardization in how we actually operate and observe and troubleshoot these environments? So Aaron's going to take it away.
All right, thanks, Richard. So I'm going to talk to you a lot on the Datadog side of this story and how basically your container journey, no matter sort of how you slice, dice it, or deploy it, or package it, or ship it, I guess, you can still keep an eye on it regardless of sort of where it is and where it lives and kind of how you want to really monitor it. So a lot of what you will be seeing, at least in my slides before we get to the demo side of it, is going to be a lot of what you get out of the box. When you first set up Datadog, if you're already a Datadog customer, awesome. Hopefully you're also a GCP customer at the same time. If not, hopefully you will be after this presentation. But if you happen to be a customer on the EU side of Datadog, that's actually that's Datadog deployed in Google Cloud. So if you are a Google Cloud customer and you're over in the EU, and especially if you have specific EU, GDPR requirements, things like that, that's the place where you will end up, and it's actually where it's deployed to. So that kind of shows sort of our investment in Google Cloud from Datadog's side. But I'm going to show you what you get kind of out of the box. It's really interesting, the amount of information we already kind of show you. And I'll be honest, when I look at a lot of this stuff too, it gets pretty overwhelming. But I'm going to try to sort of explain it and break it down piece by piece and sort of show you the different ways you can observe not just your container workloads, but even those compute workloads that he's talking about. So that we can kind of get a better understanding of sort of where maybe you want to go with your stack, or if you've already got a whole bunch of stuff going on, you just need to get a better look at the state of everything before you start making these big decisions. He's got all those questions that you saw. Hopefully you wrote them down. If not, check out the slides or the recording afterwards. It's a lot of great information that I think is very helpful. But let's go right to it, because talk is cheap. Let's get right to at least one of the first things you'll probably see once you connect your account. A question you might have too is how you get Datadog into this. So we do have great documentation and help on our docs website. We also have really, really friendly support folks. So if you've got questions, you can just raise questions there and we will walk you through these things. But once you connect that account, it's usually through something like Stackdriver. You can actually connect the Datadog agent, and then we will start generating these dashboards for you. So this is one of the first ones you might come across when you go through your Datadog dashboards list. This one is kind of GCP at large. So this is like the 10,000 foot view, if you want to call it that. It's got everything that you would normally see there. It's got everything from the events in the left-hand side with the Google Cloud Console. So it's going to tell you about any sort of operational things it's doing. I would imagine for like autopilot and stuff like that, maybe the decisions it's making might show up here, that sort of thing. And on the right is a much more large, like I said, 10,000 foot aggregate view, because if you look at the top left there, I've got the scope as, scope and region as stars. So this is everything. And this is a fairly large deployment. It's, some of you may have really big footprints. Some of you might have, small footprints that will eventually grow. And so this might look a little crazy and busy, but this kind of gives you the state of things. And this is actually a really good view to have, like, whenever we get to, back to offices again, if that's a thing that you like to do, you can put this up on a very large TV and kind of have it as sort of like, this is the state of the world currently. Sometimes I even like to have stuff like this up off, if you got multiple monitors like I do, if you've invested in your at-home, remote work setup, you might have this as sitting up off to the side, especially if you sort of live in the kind of operations world, maybe as a development side, you can kind of keep a passive eye on sort of what's happening. But it's not going to give you a ton of detail about specifically what's going on and where, unless you dial this in. But it's a good sort of starting point to kind of just give you that overall look. But it comes right out of the box. You can always just clone this and make your own copy of it if you want to sort of pare this down to something more particular. If you're not using particular Google services too, you can just remove them from the dashboard. So it's entirely up to you to customize it any way you see fit. And speaking of compute, which you mentioned before, this is going to be the more compute-centric view, and it kind of shows the miniature version of, I guess you can almost call like the famous view for Datadog. If you've ever seen the Datadog booth at a given event or a thing like that, or even if you just looked at some of our web demos, kind of that hexagonal view of your hosts, where it's actually monitoring each individual one and kind of giving you that sort of overall view of the state of things based on maybe CPU load or system, IO load, or maybe network load, that sort of thing. This kind of gives you that overall look of things, because maybe you're deploying your containers, say on Google Compute Engine. Maybe you're used to running stuff just through Docker itself. maybe you've got a bunch of bespoke scripts that are running, Docker Compose, that sort of thing. There's no shame in that game, really. It's however you and your team sees fit to kind of run your containers. Even if it's at this level, even if you're doing it through bare metal and it's going from there, maybe you want to eventually move up from there to something more orchestrated like Kubernetes. In terms of scale and all that, like the thing I want to kind of really drive home with all this stuff is that you get these nice sort of 10,000-foot views here with these dashboards. And again, these are kind of out of the box, and they will be a little overwhelming at first if you aren't knowing what to sort of look for and look at. But at the very least, you can kind of get a better sense of sort of your entire infrastructure, and then you can even zoom in on particular projects so you can kind of keep that passing eye. And you can even pass these around teams. You can limit to which teams can see these, of course, if you have very particular controls and restrictions you need to do. But ideally, you should be sharing this with as many folks as possible because, hey, I'm all about DevOps and making sure people can talk with each other about these things when you deploy them. But you can here look at the more specifics of what you need to consider when you're doing compute on GCE, I should say. There's a lot of acronyms. I try to remember each one. So GCE, when you're running those, maybe those VMs or bare metal instances, that sort of thing, you're going to be paying a lot more attention to the underlying stuff like networking, I/O, is my disk full, things like that. Stuff you're not really going to be paying attention to necessarily in containers, but it's the thing that you might be deploying containers on top of. So you now need to manage both of these things in the layers and stacks. And so keeping an eye on both through this sort of view can be helpful. But if you're going to be more interested in performance, we've got a few different other views than this. Now, I did invoke the magic word Kubernetes. So let's take a look at the Kubernetes view that you will get if we detect that there's a Kubernetes installation. So if we start seeing this, we will pop up this dashboard for you automatically. And this gives you the more Kubernetes-centric look at these things. Because remember, Kubernetes is one of those orchestrators that's out there. It's it is by far the most popular at this point. There's a lot of different ways to run them, but it is definitely the one that a lot of folks are very, very interested in because Google at large uses it. They were the first to open a service that could be used for public consumption there. And so if you have that set up, if you are deploying onto GKE or considering doing that, maybe you are not saying crazy and saying you're very you've taken on a very strong level of interest in running everything yourself, I should say. And you maybe run Kubernetes on, say, some GCE instances, like you're running your own etcd. You're kind of doing everything because you need all of the controls for whatever reason why your team. It's by far the most complex way to run Kubernetes because you need to manage a lot of things at once. But this particular view will give you everything you need to know about sort of Kubernetes in the state of how many clusters you're looking at, the namespaces, and especially things like pods, because pods can contain one or many more different containers. So if we looked at just the containers, you can see the containers outnumber the pods by a somewhat decent number. This number can even be inverted heavily, where I can see 10,000 containers and maybe 2,000 pods. And that doesn't necessarily mean it's an unhealthy or bad deployment. It just means it's your workloads doing kind of what you need there. Now, if you look over to the right in the CPU utilization per node, it looks like we're doing some serious level of bin packing there because those are some really dark hexagonals going on. So that can either be a really good thing or it could be a bad thing. And the nice thing you can do with this is you can, again, copy this dashboard. You can maybe put in some additional notes for someone who might be a new SRE starting. You give them this view and say, this is kind of our Kubernetes in a nutshell. This is how we deployed everything. But it doesn't really matter where all those containers, sort of live. I mean, these are the ones that are being managed by Kubernetes. And in that previous, view that I showed, that would be, more on the compute side of things. Maybe you want to look more at the Docker side of things. Because if you're running, say, a set of Docker containers that are being managed by Docker itself, and then maybe you're starting to migrate stuff to Kubernetes, you can kind of have a newer homogenized dashboard that shows both of these things. So you can kind of watch these containers. Maybe you need to look more at the performance and price comparison. Maybe your containers somehow run better on certain GCE nodes in your particular configuration versus how Kubernetes runs them. And you need to find out exactly why that is. Maybe there's a particular reason why, maybe it's a certain type of compute that you need, that sort of thing. And so I would, again, like I mentioned, that hexagonal view, I have to show this because this is kind of the thing that we always show in the booth, because it's a really cool view, honestly. I really dig this view. It's a great way to kind of look at sort of your overall look and feel of everything going on, sort of in terms of if you're doing traditional hosts, so talking about the lift and shift strategy, where if you had a bunch of things living on VMs, maybe bare metal, that sort of thing, this is kind of the view you're going to be, initially looking at too, to kind of just look again at the state of all those systems, the number of clusters you have in each maybe given region if you're going multi-region. So we did mention multi-cloud, but multi-region is definitely something you should start considering as well, just so you have some sort of disaster recovery scenario, that sort of thing. And there could be a whole bunch of containers running on these, but how do I know where we look? But luckily, we treat hosts and containers kind of the same way, not like exactly the same way, but pretty darn close. So if I just change that dropdown at the top left to containers, I have that same view, but now I see how many containers are living within those hosts. Entirely different viewpoint, same sort of information, but we're now looking more specifically at the containers that live on those hosts. So assuming those hosts are okay and healthy, like I showed you before, when we get to this view now, we can see sort of how each of those containers is living. Maybe one container is having a bad time, but the host is completely fine. So this is where we can look at these containers. And the other thing I should also note here is that we don't know where these containers specifically are running in this view. And that's okay. It doesn't really matter that they're running in Kubernetes. It doesn't really matter that they might be running in Cloud Run. It doesn't really matter that they might be running on Docker with Docker Compose, that sort of thing. To us, they're just containers. And you at that point can look and compare them sort of as their own selves, almost as if they're another little VM running on your system, because effectively that's what they are when they're containers. They're really, really tiny little operating systems that you can run, tens of thousands of. There's, as you can see in this one, there's a very large deployments. Maybe you can even see this view too, like where you have your largest stack deployments in particular regions, that sort of thing. With this particular demo, we have like a lot of stuff deployed everywhere. So it's a really cool way to do it. But again, these views are more focused on sort of the nuts and bolts, kind of the underlying things like networking and IO and all this other stuff that you're looking at. But maybe you want to look more particular at sort of the performance, like how are each of these containers, comparing against each other, either in the same sort of maybe system. Maybe you want to look more particular at, Kubernetes performance versus maybe you're running it on bare metal, that sort of thing. So that's where we would shift over to a different view that we have, that's the containers-based view. And I'm kind of giving away a newer feature that we've got that's really, really cool, that kind of reskews this particular view into the Kubernetes style view if you're using Kubernetes. So you can look at more specifically pods, deployments, stateful sets, things like that. So if you want to look at those, in particular, we can group those resources together. So this one is just the overall containers view. And now if you're running very large Kubernetes deployments, sort of like we do at Datadog, we have lots and lots and lots of clusters all over the place. So looking at this view and the internal side, which I can't show you and everything, is a lot of containers. So switching it to the more pod-centric view and everything might give you something a little bit more it's a Kubernetes focused, because again, those pods can be any number of containers. So sometimes you want to look at the overall pod because that might represent an entire sort of cluster as part of a service, because maybe a service requires a few things with it. So that whole pod might contain several containers that are all required for that service to run and operate. But when you're looking at it from the observability side of things, like it doesn't entirely matter. You really want to know that it's able to, not only work and function, but maybe, where that pod lives in a particular set of compute nodes. Maybe you want to compare like one set of nodes versus another. So maybe you're not using, say, autopilot yet or something like that, and you want to compare maybe one pod's performance on a particular type of node in, say, GKE. You have it deploy like a high performance node versus, maybe an average or like a GPU-oriented one if you're starting to do some more AI-based things and stuff like that. You can directly compare sort of the performance of those pods and all the containers within them against each other using this type of view. So you can filter a group, and you can even turn those into, sort of live monitors. You can look at sort of the network flows that are going in and out of those too, because the thing you really have to think about more and more as you kind of go up the complexity stack, like towards the, say, Kubernetes side, that sort of thing, you really want to, not just consider the sort of IO, which is, how well it's accessing the disk if you need that, or its memory access, that sort of thing, but also the networking between all these things. Networking alone is a really, really big deal, as we've heard in the last couple of weeks now at this point, through DNS-related outages, even within clusters like this, or even network-related outages. Those are things you really have to keep an eye on, especially once you start moving up higher in the stack. Now, if you go with something more of like autopilot, or if you go with more like Cloud Run, you're kind of handing a lot of that complexity back over to Google and saying, here, Google, I might plug it into Datadog to keep sort of an eye on it so it can see what's happening, maybe know what sort of decisions Google's making, about my infrastructure. But I don't really, my devs don't really need to handle that level of complexity. But maybe they need to keep an eye on it too. Maybe there are some more mission critical things where you need that throughput. And that could be where you need to actually start to maybe step in and have some intervention. This is where you would actually start building some more robust monitors to keep an eye on specific parts of those things. But the more of those complexities you can take away as you move up and down the sort of stack in your cloud migration, the more you can kind of keep an eye on that stuff. But we're right up at the demo side because slides are really cool, but let's actually show you the app itself. So let me change my view here to show you the toolbar here. There we go. All right, so let me get to the fun demo part. So let's get to that first thing that I was showing you before, the Google Cloud Platform stuff. So this is that same view. I kind of shrunk it down a little bit. I'm actually going to blow it up here so you folks can see it a little bit better. But as you saw, there's a lot of information there. I've got the events. There's not much happening now versus what was shown in that initial slide there because I kind of messed with it a little bit so it'd have a lot more information in there. But this is kind of that first sort of thing you get right out of the box when you first attach Google Cloud to your account with Datadog. And I wanted to more specifically call out some particular things here, but this is scoping to everything. So I'm going to dial in the scope a little bit here. So maybe take a second. There's a lot of stuff inside of this account here. So let me do some availability. And let's see if I can actually type, because usually when people are watching me as I type, I can't type anymore. See Central, of course. There we go, Central 1A. All right, so we're going to zoom into this particular availability zone. So now we can actually see more specifically what's going on in that particular region. Now, there's only compute engine resources in this particular area. So it's only showing me this part of it, but over here, it's a little quiet. There's not a whole lot going on here. So maybe we don't have anything in App Engine or Cloud SQL or anything like that. So maybe I want to create a clone of this dashboard, delete all this other stuff, and maybe have just one where I'm watching this particular region. So these dashboards can be, copied and modified, and whenever Google comes out with another, I'm sure they will. Like, I don't know, if Richard wants to spoil anything today, but there might be some newer product that comes out, and we will of course update these default dashboards for you. So this dashboard, this default one, will change. As things progress, things change, we add a new integration, something like that on Datadog's side. So if you want to customize it, you can. If you want to leave it as is, we will eventually modify this to kind of move with the times, that sort of thing. But one of my favorite parts about this, these views, these default ones too, especially if you're newer, like I tend to be with some of this stuff, I always try to approach the stuff with a new set of eyes if I can try to learn and see from the new user's perspective. But if you go to the top left up here, it says Google Cloud Platform. There's a little actual drop-down thing here. So if you click on that, we give you this really interesting view that I always recommend for new users, especially. Even if you're already an active user of Datadog, there's a lot of folks who just don't know this exists. But this is going to be in a lot of the default dashboards that you see. And we give you links to our not only our docs and everything, but also helpful blog posts, because our engineers are really, really great at writing some awesome content that we very heavily curate. So if you were not sure exactly what Google Cloud offers you in terms of the information that they give to Datadog, et cetera, all that stuff that's there, we kind of try to link you to as much of it as possible so you can see. And then based on sort of what your team is doing, we try to suggest other dashboards that you can go look at. So maybe if say you're brand new to a company and they just started deploying stuff to Google Cloud Platform, they just decided we're going to migrate everything. You're new to the company. This might be the first place you want to stop, so you can kind of see at a glance where are we at in our deployment? What's going on? Are we moving everything to GKE? Is it all going to be on autopilot? I don't know. This is a good place to start. And also maybe a good place for you as an employee to start of okay, what do I need to know about, Datadog watching the stuff? And at that point, that's also where you can start those conversations internally of okay, so what are our goals? What are our strategic goals about what we need to do with this particular platform, and making sure that we can get the most out of it. And so the next sort of side of this too that I want to show you is the GCE side, the compute engine. So back to that previous screen that I showed you before. Now, let me actually make this a little bit bigger. So I'm going to minimize this. So this is where we get the compute side again. But here, as you can see, we're not only running some Kubernetes on the compute engine nodes, we've got Docker running. So the Docker underneath is actually part of the engine that's powering the Kubernetes cluster. And then from here, we can actually see more of the host level stuff that we would want to look at. So if you're going the route of saying, maybe you're going to start moving things into containers by doing a different sort of variation of lift and shift. Maybe you lift and shifted stuff over, and now you're looking at it and thinking, like, maybe we can get more out of these large VMs that we're using. And so let's start containerizing things. So maybe you'll just start putting them into Docker containers and just having Docker run them. That's a very easy way to start, and this could be another way for you to look at that particular migration story. And once again, I'm gonna pull up the same zone, the compute zone that I had before, because I kind of want to show you that the same information, we're going to look at this in sort of different sort of views and looks here, because I didn't show you the Docker-based view. Ability here, zone. I know this is going to be, I should have just had this totally copy paste here, but I felt like I can totally type this without.
It's still very authentic, Aaron. Don't worry about it.
Yeah, I'm trying. Oh, of course I couldn't get it. There we go. Let's see here. Availability. Oh wait, I need to put it inside the scope. That's right. There we go. There we go. Got it in the right spot. Central. 1-A. There we go. So same availability zone that I showed you before. Now we're going to look again at that same view that I showed you previously, but now this is, again, scoping it more specifically to the compute engine. So maybe over here, I had zoomed in on this and I noticed this is compute engine specific resources. I can go to the compute engine dashboard and now look at that side with a more dialed in sort of view of that. So now I see how many instances are running. I can look at a glance and see, like, okay, some of these are a little overloaded. Maybe I need to go take a look at that. Maybe I don't. Again, this is something you can take a look at and just have a sort of like that passive view. It's not really going to give you the more specific, like, I need to look at the performance of each of these things. And then I'm going to move to that same view again, because we saw that there was some Docker stuff running there. So I'm going to once again pull up that same scope. I'm going to type this in again. I should be able to get it again this time. And there we go, US East, or US Central. There we go. All right, same view, but now we're actually looking at Docker more particularly. So we're looking at just the containers that are happening to be running on those hosts. And this is, again, the container-centric view. So not really looking at necessarily the I/O. We're looking at well, I/O in a way. We're looking at the CPU, the memory, system usage, that sort of thing, because at least for the containers themselves, we want to make sure that they're running on a ideally healthy host, and also making sure the containers have the adequate resources to run the workloads you're throwing at them. And also, we kind of want to know what Docker is doing under the covers. We want to see, like, what's up with Docker, and if Docker is deciding to kill stuff off, we probably want to know, especially if it's a core service. Is that a thing we should be paying attention to? That sort of stuff. If there are containers that are not running, then we won't see that 100% utilization up top. Is that a problem? Maybe containers aren't starting. There's a bad build, bad deploy. That's something where we might be able to see this surfaced in this particular view. So the next part I do want to show, like, this is the Kubernetes side of it. I'm going to rush through this a little bit just because I want to get to our Q&A time. But I'm going to show that same information one more time here. So I'm going to zoom in the same scope here because, again, we have some Kubernetes stuff running there. So I'm going to show that, and then I'm going to show you the containers particular view, so that way you can see the same, again, information that we're showing here, but we're showing it across each of these different dashboards that, again, all came out of the box. They're all detached immediately when we can detect these things inside of Datadog's agent. So let's see here, availability zone. I'm going to be able to type availability zone like super perfect after this. That'd be great. There we go. Cool. All right. So we're going to now zoom into the Kubernetes particular view. So we can see in that same availability zone, we're running at least 4 clusters, 14 namespaces. We have 300 pods. So this is quite a decent size, I'd say, give or take, deployment. There's a few things going on. But we can see more specifically, sort of the health of those pods, especially across namespaces, things like that. And we can also see sort of the actions that Kubernetes has taken across these things. So if Kubernetes is going to be cycling pods, it's going to be moving stuff, et cetera. We can see those as they come across. And this is stuff that you want to start keeping an eye on, especially once you start moving into Kubernetes. Now, if you hand a lot of that complexity back over to Google by way of, say, autopilot, it's like, I don't want to think about Kubernetes networking. That's something we're not really talking about today. That could literally be its own multi-hour talk, because Kubernetes networking feels like the new frontier / hotness. There's a lot of stuff you can do with networking when it comes to software-defined networking. And that's just something I'm not covering here, but it's, again, something you need to consider when you start moving towards these more complex solutions, I should say. There's nothing necessarily wrong with it. Just know what you're getting into when you do that. But again, the nice thing is we can still show these things out of the box and give you some more information that you really ought to know when you start getting into these types of deployments. And so I'm going to go right over to that last view here before we start taking questions and answers. So I'm going to breeze through just a little bit. So this is that containers view that I was showing before. This is kind of the more, like I said, performance-centric one, where if I wanted to more directly compare containers against each other versus like with those dashboard views, we're kind of taking the more host level, like sort of zoomed out view. If I wanted to zoom more into, in this case, we've got a lot of Kubernetes-based containers running here, so they're part of larger pods. So if I switch to the pods-based view, I'm now getting the more grouped look at those things, because some of these pods, again, like some of these are single containers, some of these are multiples. It depends on really how you're deploying and sort of managing your whole stack. But we can take a look at these labels. We can then look overall at the performance of each of these within this cluster. Because if you see here, I've got my availability zone dialed in, again, from before. I kind of dialed this in ahead of time because I was thinking I would end up having this problem of typing. So I'm back to that same cluster as before, and now I can see all the services that are running. So I can actually even zoom into particular ones based on their status. That's something you're not going to get from those initial dashboard views, because like I said, those are just kind of giving you the whole state of the system. This is going to be more of like, maybe I'm a dev and I need to see like how my new deployment worked inside of the Kubernetes cluster. Maybe I'm just doing some basic performance tests, or I need to see if the newer workloads are working the way I expect them to. Maybe we need to just immediately scale up some pods. Who knows? So this would be another way to be able to look specifically at those things. But again, like this is the more Kubernetes specific view. If I go back out to just containers here, we are identifying these by the sort of icon, or sort of what we can detect them running as part of. But maybe these could be standalone, just Docker containers. And from here, we can even just, as containers, apples to apples, compare them to see how maybe they're being scheduled one way versus the other. Because we are talking about Kubernetes and all that stuff too, but maybe you're using HashiCorp's Nomad. There's a lot of different ways you can run this, even on the GC side of things. Like I said, there's also Docker Swarm. There's quite a few different, Mesos is another one too. But the thing is like at the end of the day, those are all still containers. They're just being run by specific orchestrators. And so this would allow you to see kind of those containers no matter how and where they are run. So you can then compare and contrast the performance. So let's go ahead and go right to the Q&A section, because it looks like we've got some questions. Right, Richard?
We do. I've answered one in the background, but we've got a couple that we wanted to chat about in general. Aaron, as we look at, we should tackle the first one as you ask yourself. Do you have to put an agent to monitor these containers? Are you just magically detecting them? Tell us what's happening.
I'll just say it's complicated in terms of an answer. It's a yes and no. So yes, in general, you usually have to run an agent somewhere. And there's different ways you can run the agent depending on how your sort of deployment is. If it's in serverless, that's a little bit different of an answer, just because we have a particular set of ways you can run that through serverless. But most of the time, it's going to be through an agent. But if you're going to go, let's say, the Cloud Run route or something like that, we have a different way you can do that. It's all documented, of course, and if you have questions, feel free to ask offline.
Awesome. We have another question in there about deploying containers in Google Cloud, best options. So as always, there's going to be a built-in option as you'd hope for. So Cloud Build is our CI, somewhat CD solution that can also do things like use Cloud Build Packs and say, even if you don't know how to build a Docker file, which I just steal them from Stack Overflow, so don't feel bad, that you can use things like build packs to just generate the actual container artifact from your code, use Cloud Build to then deploy it to Kubernetes or Cloud Run. But again, at the same time, anything can work with that, whether you use Jenkins, whether you use a hosted CI tool. So you have lots of ways you can build and deploy containers, things that we provide in Google Cloud, but we love our ecosystem. So bring your favorite tool.
We have a question here. What is the largest deployed configuration?
We'll see. Well, let's say that's an Aaron question.
Okay.
Largest deployed configuration. It's a little general. I'm not sure what you're referring to in particular. Configuration in terms of containers?
Yeah, there are upper limits, though, in terms of how much you can, what's the most you can monitor? You monitor thousands of things, tens of thousands of things?
Oh, yeah, it's definitely in the tens of thousands. I think for some of our customers, it's literally in the tens of thousands. Not sure about the hundreds of thousands, but definitely tens of thousands. There's some very large customers that we have. Some of them I can't disclose for reasons. Is the best way I can put that. But no, we have some rather large, like Fortune 50 companies and stuff like that manage very, very large deployments with us.
Yeah, and in case it's for GKE as well, we actually have the most scalable of the Kubernetes. So we can do 15,000 node clusters. You can obviously put lots of containers per node itself. So that's 5x any other public cloud. So we at least have some pretty giant configurations for GKE as well.
Yeah.
Raj says his question is silly, but I don't think it's that silly. For fintech companies, how much data can be stored and analyzed proactively for at least 10 years?
Okay, so on the Datadog side, that's an interesting question because it kind of depends on sort of what you're sending to us and storing. I didn't really show the log side of things. So one thing you can do when you're sending, say, log data to us is it can be stored off into cold storage, and then if you ever need to access it for whatever reason, if you connect that to, say, Google Cloud, you can actually rehydrate logs from the past in case you need them. But for the most part, it'll be whatever you sort of set up as a contract with us for the level of retention for active searching, because we'll have kind of the warm pool that you can see immediately, and it's up to a specific amount of time back. It depends on how much time you really need. And then from there, you can have the log pipeline move everything that's beyond that timeline into cold storage. And if for whatever reason you need it, say, a few months from now or maybe a year from now, and you need to rehydrate those to maybe look at maybe there's a container issue or there might be a compliance thing, that sort of thing, you can dial the clock back and rehydrate it back into your Datadog instance so you can take a look at it. Hopefully that answers your question. But if it's like particular like compute data, that's a different thing.
Okay. And then follow up to the largest deployed configuration question. 15,000 nodes, how much compute resources, or how many compute resources? I would assume the question means how much compute resources does that take up?
Yeah, just in case, I also put a link into I'll publish it to the calculator. So if you, for fun, want to play with what it takes to actually pay for that, you can feel free to. And that's an abnormal configuration. Most people are not going to deploy clusters that big because they don't need to. They're going to have many smaller clusters because they're going to isolate them by app or region or department. So in many of these cases, the compute resources, a node is more or less a VM today underneath the cover. So if that would be equivalent of 15,000 VMs connected through one control plane, one ingress, all that stuff. So it's pretty remarkable that we can pull that off. At the same time, most people are doing obviously smaller nodes and just kind of smaller, healthier things. And as Aaron showed, it really doesn't matter from a management perspective because you're able to see all of them kind of wherever they are. So you figure out what the right model is for you from a support perspective and an ownership perspective if you want few big clusters or many small clusters.
Absolutely. And I will say, at least from the Datadog side of that story, if you kind of want to know what Datadog's sort of level of deployment, that sort of thing, we have a whole series called Datadog On. So if you do a search for Datadog On, but I think it's datadogon.datadoghq.com, you can sign up there. And that is a particular series live from our engineers about how we do particular things like our Kubernetes deployments, how we do secrets and things like that. We answer live Q&A for those. I think they're every month. So by all means, check those out. So we've talked in the past. There's great ones that are already there for how we do these larger scale container-based deployments. Because definitely, I don't know the exact number, and I can't really give you specifics of those, but I know it's in the thousands for us. Just don't know how many. Because we have like 3 major deployment environments now. So.
Okay.
It's big.
Yeah. Well, with that, I think it's just about time for us to wrap up here. Just a quick reminder to the audience that today's webinar has been recorded. So if you missed any of it or want to go back over something again, you'll be able to do that. We're going to send an email with a link where you can access the webinar on demand, or you can find it at devops.com/webinars. All right, it is also time for us to draw the names of our 4 Amazon gift card winners. So let's see what we've got here. Okay, our first winner is Juliana K. Congratulations. And next up, we've got Dan M. Dan, congratulations. And next, Walter P. is our next winner. And finally, Linda G. Congratulations to all the Amazon gift card winners. We'll be sending an email out with instructions for how you can claim those. So check your email inbox. And if you don't see it, make sure and look at your spam folders. All right. So thank you both so much for an awesome webinar. It was great to spend an hour with you. And thank you so much to our audience for joining us. We hope to see you at more webinars in the future. Thanks again. And I'm Sharon Florentine signing off.